What is going on, guys? Welcome to my channel. In today's video, we'll be talking about how to use NMAP. We'll start off the video getting an understanding of the theory behind NMAP. Instead of just running commands at the terminal, we want to get an understanding of what's happening on the networking level. To do this, we will be using Wireshark. From here, we'll go into how to actually use NMAP and how to use NMAP commands. We'll go through some go-to commands to understand TCP and UDP port scanning and understand live host discovery. So without further ado, guys, let's get right into this video. Let's talk about how the NMAP program scans ports that run the TCP protocol. So if you are running NMAP as a low privileged user, by default, it will use the connect scan. So if you're not using sudo or if you're not the root user, it will use a connect scan. And how this works is very similar to a TCP three-way handshake. So here we have our Ubuntu web server, and we have our host here, which is a Kali machine. So here we are going to send a SYN message to port 80, which is the first part of the three-way handshake. And if this is open and listening on port 80, it will respond with a SYN acknowledge message. And finally, we will send an acknowledge message to port 80. If this three-way handshake completes, then we know that we can make a connection to this port, and therefore it is open. Now let's talk about the SYN scan, also known as the stealth scan. This scan is not actually stealthy, it is easily detected by firewalls. This scan is the default scan that is used if you're running a shell as the root user or if you prefix your command with sudo. Let's say we are sending our SYN message here like previously. And if this port is open and listening on port 80, it will respond with a SYN acknowledge message. And after this, our host here will terminate the connection. It won't complete the three-way handshake, and this will save us time as we know this port is open and there's no point in completing that last acknowledge message. Lastly, let's analyze what will happen if this port is actually not listening on port 80. So here we will send our SYN message again, and the web server will respond with a reset acknowledge message, and that will indicate that this port is in fact not listening and is closed. Okay, let's talk about how the NMAP program is used to scan ports that run the UDP protocol. So firstly, the UDP protocol is a connectionless protocol. That means there is no handshake involved with the UDP protocol, as you know with TCP. Instead, in UDP, you just send packets and hopefully they arrive at their target. Let's assume we are scanning this target here, which is a Windows domain controller server. Don't worry too much about what this is. All you have to know is that this server usually runs DNS, which operates on port 53, which is a UDP protocol. We are scanning this port 53, which is UDP. So first we are going to send our packet to see if this is open, and our packet will be redirected to the application layer if this protocol is in fact running. And depending on how the application layer is programmed, it may be programmed to send a response back, or it may be programmed to send no response. In this case, we're going to assume that the application layer is programmed to send a response back. And if there is a response, we know that this port is in fact open and listening. All right, let's discover the case when the port is closed. So again, we will send our NMAP packet, and we want to see if this port is open. So if it is closed, it will not send any data to the application layer and immediately send back a ICMP port unreachable message. This is how you will know that this port is closed. Although this is not the message every single time, a majority of the times this will be your message. As we mentioned before, sometimes when we are scanning UDP ports, the application layer is programmed to not send any response back. And in this case, the port is still open as there is a protocol running behind this port and there is a service running. But at the same time, sometimes you may have a firewall. And this firewall will filter any traffic going to the ports on this server. So maybe it will see this NMAP scan and it will block it from ever reaching this port. And in that case, if it blocks this traffic from going to the port, no response will be sent back to our host here. And in that case, we'll have no response. And now we have a little bit of a tricky situation because the firewall will give no response, but sometimes when it's open, the application layer will also give no response. So in that case, we'll get the following results back from NMAP. Here it shows the port could be open or it could be filtered by a firewall, and we don't know its exact state. Now I will demonstrate what I had just shown you, but in Wireshark, so we can do some packet analysis and see what is happening. So first we are going to scan our host here on port 80, see if it is running anything. Here we can see the state is closed, port 80 is the HTTP protocol, and as expected, we are not running a web server, so we do not have an open port for port 80. We'll look into Wireshark, and right away we can see what we had just demonstrated earlier. You can see the SYN message that's sent originally to port 80, and we immediately receive a reset acknowledge message which terminates the connection because this port is not in fact listening on port 80. Now we will start up a web server on our host. And now we will scan our host again on port 80. And let's go back to Wireshark to see the results. Here we can see our SYN message, our SYN acknowledge message, and then our reset message here. And the reason we don't have our full reset, our full three-way handshake here is because we are running as the root user, and the root user won't complete the handshake. It will terminate the connection after our SYN acknowledge message. Here we'll switch our user to Kali. We'll run the same command just for proof of concept. And here we can see we have our SYN message, our SYN acknowledge message, our acknowledge message, and then the connection is terminated. All right, now we are going to scan our own computer again, but now we're going to scan for UDP. We're going to use, don't worry too much here about the switches, we'll explain this stuff in just a bit. So here we're scanning for UDP, specifically port 3333. Since we don't have anything running, any service running behind this port, it does say it is closed. And here we can see right away we have that destination unreachable message with ICMP here, as we expected. Now what we're going to do is we're going to start up a UDP server that's running on this port. So first, quickly, we are going to configure our server to send a response. And you may be able to foreshadow what is going to happen now, as we know what should happen if UDP sends a response. Now we have our UDP server listening on port 333 on our host. We're going to run that same command. And as we expect, it shows that this port is in fact open. And here we can see, here is our host sending our message to port 3333. and this is the response we get. And you can see it is decoded to show this port is open. Don't worry too much about this destination unreachable message because we did get a response. And if we do get a response, we know that the UDP port is in fact open. Now let's go into that special scenario where there is no response and is not sure, and NMAP is not sure the state of the port. So again, we are going to edit our UDP server. Don't worry too much about any of this stuff. It's just to show what is happening on the networking level here. So here we've configured our server to send no response. We're going to start up our UDP server again. And we're going to run that same port, that same command. And here we can see it is open or filtered. NMAP is not sure the status of this port. If we go to Wireshark, we can see here that it attempted to send the message to port 3333, and it attempted to send it again, and both times there was no response. Let's dive right into how to use NMAP. So we'll start off with how to use NMAP for running scans to find open TCP ports. So how I set this up was on the left here we have a command that is typically run by IPsec, who is a renowned name in the space, if you haven't heard of him already. And on the right, we have a command that was taught by the Cyber Mentor, which he typically uses in his penetration testing endeavors. So I wanted to show you guys two commands that are popularly run by two big names in the space. And this command is the command I usually go to when scanning machines, and this one is also very helpful. So let's break down this first command here on the right. So we start off by running our NMAP program, and then this shows this stands for your scanning speed. So how aggressive do you want to scan? The default is T3. T4 stands for an aggressive scan. It'll just speed up the process a bit. Your -P- stands for all ports here, so you will scan all TCP ports possible. -A here stands for operating system detection, version scanning, default scripts, and trace route. So what this will do is it will scan, do your typical NMAP scan, but it will also try to guess the operating system. The operating system guesses. It doesn't provide a 100% accurate operating system. It will provide a confidence level, as you can see here, in some possible operating systems. NMAP isn't able to provide a 100% confident guess as of yet. You can also see here in this all switch, it will provide the versions here. So you can see the version here of the IIS Windows server. And it will also run some scripts. So it'll run some scripts behind the port to actually interact with the service itself. And here we can see for the file transfer protocol, we have anonymous FTP login, which is allowed. So let's jump right back into IPsec's command. And I will show both their YouTube channels here on the screen. IPsec's command here is a bit different. So here you run your default scripts for this first switch. Your next switch will enumerate the versions for the protocols. And this last switch will output the results to 3 different types of output files. So as you can see here, you can see your versions here beside your protocols. You can see what's happening from your scripts and your results here. And if you go into the NMAP directory, which we sent this output file, you can see the 3 different outputs here. The NMAP is your normal output, your GNMAP is your greppable output, and your scan.xml is your XML formatted output. All right, let's waste no time, guys, and go straight into our UDP scans. So to run a UDP scan, you want to add this SU switch, and by default, this will run the top 1,000 ports that NMAP has in its program. And just to go back quickly here, this will run by default. If you don't include anything with the P switch, it will run the top 1,000 ports in the NMAP program. So if we go back to the UDP scans here, we'll run the top 1,000 ports on this IP address. And here we can see that 998 ports were open and filtered. So these ports are actually not shown, as we mentioned earlier, what an open and filtered port is. This is when no response is provided, and NMAP is unsure of the exact state here, so it doesn't actually show you all those ports, but it does show you two ports here, port 161 and port 500, which show the open state, which means there was a response here. Let's say you do want to see the state of these ports. Maybe you want to know if one of them is potentially open. What you can do is you can run your default script. So you can essentially run this exact command here, but we are adding our default script switch here. So we're going to run some scripts to try to interact with our services to see if we can gather any information running behind that port, to see if there's actually a protocol that is running behind that port. Here we are just scanning the top 20 UDP ports. So by default, this runs the top 1000. Here we are just setting our top ports to just the top 20. And if we look through our results here, we do just come out with the same ports here, 161 and 500. But in other situations, this does help in finding other ports that are actually open when you have that open filtered result here. All right, let's do a ping sweep. So what a ping sweep does is it essentially sends ICMP packets to a provided subnet that you give it. So it will scan all the hosts in the subnet. It'll send them ICMP packets. If it receives a response, then it'll mark the host as online and alive. Let me show you the command to do this. And right now we're going to be using a Active Directory lab that I have set up here. So here you can see the results just off the top of my head. I know this is our host that we're using right now, our Kali host. This is our domain controller, and we have some other hosts online as well. So just a note, guys, with NMAP, I haven't showed everything in this video. I suggest you guys practice using NMAP with different switches and get familiar with what you like. Maybe you'll like a specific set of switches to use for your commands. If you want to find the manual page, you can go on Google and just search up manual for NMAP and look through some possible commands. You can also just search it right at your terminal here. You can also run nmap-h to get a shorter version. If you guys did make it this far in the video, I hope the tutorial was helpful for you. If it was in fact helpful, please do give it a thumbs up, and I will see you guys next time.